you should do in order to get whatever grade that you aim, okay, for this class, okay. Hopefully everybody is aiming for A, all right, a grade A, all right. Don't aim this class for the at least C, okay, all right. That's a very bad aim actually, okay. So at least aim for A or A minus, okay. Because why? Because fluid mechanics is a very simple and easy course, right? Okay, if you follow whatever I told you, I tell you, okay, so you should do this, you should do this, okay, probably you will get an A for this class, okay. And by the way, this semester, I'm the only one who will teach this fleet one, all right, throughout the 15 weeks, okay. So it is not a combination of two lecturers, but it's only me as your lecturer. But anyway, we still, all right, for those who are repeating this class, all right, we still using this Dr. Hasbullah videos, all right, to help you, all right, not during the class, all right. So after the class, all right, after the class, you will use this Dr. Hasbullah videos, all right, to help you or to guide you to understand the knowledge that we will discuss live in class. Okay. Okay, for those who still not yet have the opportunity to come to UTN, so this is our school building, all right, the MS Fashion building in the E07, okay, and hopefully, all right, by the end of this semester, probably everybody, each one of you will be here, all right. Please make a dua, all right. So either the end of this semester or next semester, okay. Hopefully we can have a face-to-face class, which is a much better uh, compared to this online class. To myself. Today, what we are looking for is this. What is the agenda for today? All right. Where is my agenda here? Oh, okay. You see this? These gas turbine. All right. So this is a gas turbine, a very huge machine. Okay. Have a thousand or so RPM. Okay, in order to create power. All right, to create thrust. All right, for the aeroplane to fly. Okay, and then we have what we next we have here. Oh, this is another machine by the name of this hydraulic pump. Okay, this is the hydraulic pump. Okay, so the function of this hydraulic pump is to pump and hydraulic system, all right, for the hydraulic system. So to be an engineer, all right, to be an engineer, all right, because all of you are very keen to be an engineer, especially in mechanical engineer. So you should at least, all right, you should at least know what is the power of this pump. Okay, how much power needed for this pump? What is the size of this pump? All right, or this turbine, for example. Okay, and also for this hydraulic system. All right, so you should know. Okay, we as a mechanical is looking for the power of this all this machine. All right. Okay, so this is our function as a mechanical engineer. Okay, so it means that we need to know. Okay, and we need to do the analysis in order, all right, in order for us to decide. Okay, we design the system and then we say, okay, so we need at least 30 kilowatt of pump in terms of power, for example. Okay, all right. So as an engineer, we need to do, we need to know this. So where you can learn this? All right. So the basic of this is you learn it in SEMM 2313. Okay, even though this is a second year, we call it a second year subject, of course, but the implication of it is very huge actually. All right, because this is the the stepping stone, all right, for you to do an analysis for a machine related to fluid. Okay, so that's why I said what all of these have in common. You see, one is on the road, all right. One is flying, the other one is just in water, right? So even though we have a different location, different kind of machine, but all of this is depend on fluid, all right. Everything in our life is depend on fluid. Okay, so that's why I said fluid is very important to us, all right, especially as we are mechanical engineer, and because the fluid is everywhere, so it's supposed to be an easy thing, right? So it's supposed to be a very easy course, all right? In fact, everybody can get an A in this class, all right? Everybody can get an A because everybody have the same opportunity, all right? To seek the knowledge, to do the exercise, for example, all right? And you have the same test, all right? The only difference is you have a different answer. All right, never give me the same answer. All right, the same solution, the same kind of what is the answer? All right, because when you have the same answer, okay, you will get another TS this semester, right? All right, not complete the subject, or probably I give you automatically I give you 0 then. Okay, then you get an E and see me again next semester. Okay, all right. So what all of these have in common? It is related to fluid. Okay, all right. So our course synopsis in this case is the principal aim of this course is to provide students with an understanding of the properties of fluid. You see that? You must understand the properties of fluid. That's the most important. In fact, it is the core, all right, core for the fluid mechanics, okay, which is the properties of fluid. Okay, so since it is a core, so I'm suggesting to you, all right, it is better for you to understand it clearly, all right. What is the properties of the fluid, okay? There's only 4 properties of the fluid, which is you need to know the name, you need to know the symbol, and then you need to know the definition of it, and of course you need to know the unit of that particular properties. Okay, so it is very important. Okay, if you want to get an A in this class, right, or in order to get an A, you need to answer everything quickly, right? So in order to answer it quickly, so you must remember a lot of things. All right, when you remember a lot of things in your mind, all right, then you can get an A. All right, why? If you can do it faster, so you have a lot of time, all right, to recheck it back, whatever answer you have done before. Okay, so that's why memorizing certain thing is important when you're learning something. Okay, so in fluid mechanics, the most important thing that you must memorize is the properties of fluid. All right, the properties of the fluid. This is very important. Okay, and to introduce fundamental laws and description of fluid behavior and flow. Okay, and it will emphasize on this concept of pressure. Okay, so we will learn how to measure the pressure, but before we measure the pressure, we need to understand what is the pressure, all right, related to fluid. Okay, related to fluid. After you knowing the type of pressure, then you know how to calculate that particular pressure. And then after that, we follow by the hydrostatic pressure equation. All right, so we create the hydrostatic equation. Okay, so by the way, I like to remind you, all right, because we are an engineer, a future engineer, all right, so we not using equation to solve a problem, all right? We not just memorize the equation and then we analyze things. No, all right. That is for the what we call the technician, all right? For people who work with the machine, okay? But we as engineer, we must know how to create that equation. Okay, because different machines in different condition have a different boundary condition. When they have a different boundary condition, so probably they will have a different or slightly different kind of equation to be applied in order to analyze the problem. Okay, so it is important to you to understand and to know how to create the equation. All right, how to create the equation. So that's why when we said over here, we have the hydrostatic pressure equation. All right, so you must know. Okay, so for example, if you have the equation given it to you, all right, you should ask, where did this equation come from? Okay, how even created? What is this boundary condition for that particular equation? All right, for example, in the hydrostatic pressure equation, all right, that we will use in our class, all right, that equation can only apply if, okay, if the free surface is open to atmosphere. All right, when it is open to atmosphere, all right, the gauge pressure for the atmospheric is equal to 0. You see that? So that equation is only applicable for a fluid open to atmosphere. All right. So what happens when it is not open to atmosphere? All right. So when it is not open to atmosphere, then you need to create a new equation for that particular problem. All right, before you can do the analysis. So that's the reason why it is important to you to understand how to create that equation. Okay, so then after that, each application in the measurement of pressure, static force due to immersed surfaces, flotation and buoyancy analysis. Okay, and then dynamic flow analysis inclusive of technique in solving flow problems is introduced, especially to soft flow measurement. All right, we are looking for the flow rate. All right, a mass or volumetric flow rate, momentum in flow, and also loss in pipe network. Okay, so lastly, some basic dimensional analysis and similarities will be introduced. Okay, so I think 2 weeks, the end of the 2 weeks, week 13, week 14 and week 15. All right, we will deal with this basic dimensional analysis. Okay, at the end of the course, the student should be able, okay, at the end of the course, all right, the student should be able to demonstrate an ability, all right, to analyze whether statically, dynamically, or kinematically problem related directly to fluid. Okay, so from there, you know that our task or your task in this class is that you need to demonstrate it to me, all right, that you have the ability to analyze, all right, a fluid problem, whether the fluid is in static or it is in dynamic condition. Okay, you need to show it to me. I want to show it to you, sir. Okay, by answering the question. Okay, all right, when you answer the question, you need to put everything in detail, all right? To put everything in detail. Because why? Because you want to show it to me. You're not in front of me when you answer the question, right? If you're in front of me, then I can ask you, hey, where you got this, where you got that, where you got this, all right? Okay, but you are not in front of me, okay? You're not in front of me. So the only thing that I have in order to judge you is whatever you write on the paper. Okay, so those, especially from Bangladesh, from all these Middle East, all right, student, uh, don't answer it in your head. Okay, don't answer it on your head. Whatever in your head, put into the paper. All right, put it into the paper. Okay, so if you put into the paper, then I know the way you think. What do you think when you answer the question? Okay, if you suddenly, oh, we have this equation, suddenly you just put certain numbers there. All right, probably you get, I will give you a 0 then. Okay, because why? If suddenly I have the number, then probably I say, well, probably you got from somewhere else. Probably somebody is sharing with you. Okay, so that's the reason why you need to write it one by one, systematically. Okay, so please, those from the Middle East, all right, Middle East and all these uh, others which is not Malaysian, all right, because they have the tendency of not writing it in paper. Okay, if you're not writing it in paper, all right, so most probably I will say you are sharing with somebody. Okay, so don't make me make that decision. All right, make that assumption. All right. So in order to eliminate that assumption, please write it one by one. Okay. All right. Hopefully you understand what I'm trying to tell you here. Okay, so there's that course synopsis. So where can I get all these information? I already shared it to you, right? I think I already shared it in the e-learning. All right, all this information is in the e-learning. All right, you can check it there and download it. Okay, so what you will learn? All right, so what you will learn in our class is simple. It's only three things. All right, one is fluid properties. That's it. Okay, you just learn fluid properties. Simple. Okay, and then when you understand the fluid properties, all right, when you remember everything about these fluid properties, then you say, okay, it is time for me to apply and to use whatever the properties of the fluid into the mechanics of fluid. All right, into the mechanics of fluid. All right, so at the end of the semester, we have another topic by the what we call dimensional analysis. All right, this is the easiest part. All right, so this dimensional analysis is the easiest part of this course. All right, so you should get 10 out of 10. All right, in terms of mark. All right, whenever we have this dimensional analysis problem. Okay. All right, so the core of the properties, all right, the core of the this course actually is what? The fluid property. See how many fluid properties that you need to remember? It's only four, all right? Density, specific weight, specific gravity, viscosity. It's so simple, all right? It's so simple, okay, because it's only four. All right, you only need to remember these four, not 40, only four. All right, and you know that how it's quite easy for it to memorize all these things, because why? In order to memorize something, you need to repeat it 40 times. All right, 40 times. If you want to remember the name of this density, repeat it 40 times. Density, density, density. All right. When you take this breakfast this morning, all right. Before you drink something, density, density, density for 40 times. All right. By the end of your drinking, then you're done already. All right. You can memorize the first property of the fluid is density. So you get the name of it, density. Okay. So because it is so important, okay. Sir, why is it so important, sir? It is important because during the exam, you cannot open anything. Okay, so you cannot open the textbook, you cannot open the notes. Okay, so what you can open? You can open your mind only, right? You can open your mind only. So in order to, if you open your mind and then your mind doesn't have anything in there, so what the use of it, right? Okay, so that's why you need to put all these fluid properties into your mind, all right, into your mind, all right. So every time when you answer the question, when you say, okay, I see this rule, oh, this is density. What is the value of this density? So everything is in your head. Okay, so when everything is in your head, all right. So your thinking will become faster, and then you can answer the question quickly. All right. So it is very important, okay? Very important for you to remember these four properties of it. Okay. So what you need what thing that you need to remember. Number one is the name of it. Okay, you have 4 in front of you now. All right, and then the definition of each of it. All right, the definition of each of these fluid properties. All right, and then followed by a symbol. All right, so the symbol is very important because why? Sometimes they use a word. All right, for example, they put a density. Okay, the density of water or density of this fluid. Okay, so you see the word density there. All right, but sometimes they don't put the name. They doesn't mention the density. All right, the word exactly density. All right, it just mention. Let's say the rho is equal to. Okay, it just give the symbol. All right, they give the symbol of rho. Okay, so that's the reason why you must remember the symbol. All right. Okay, and lastly, it is a unit. All right, the unit is very important. All right, don't just say density equal to 10. 10 of what? 10 of element? 10 of fire? All right, there must be a unit at the end of it. Okay, so make sure you got your unit correctly. Okay. All right, make sure you have your unit correctly. And then all these 4 here is important and you will apply it, all right, from the beginning until the end of our semester. In fact, these properties also will be used in fluid too, all right. But the only thing is that sometimes different book using a different what we call a symbol, all right. Different course using a different symbol, but probably they say it is the same thing. For example, probably in thermodynamic they are using different symbol for density, for example. Okay. All right. So next, what I have next here. Okay, so the mechanic of fluid divided into two. Okay, at the beginning we said we only learned 3 years, right? Fluid properties, and then mechanic of fluid, and lastly the dimensional analysis. Okay, but the mechanic of fluid is divided into 2. All right, one is static, one is dynamic. Okay, in simple word. All right, in simple word. Okay, in simple word, what you are learning, all right, or what you are looking for in this fluid mechanic actually is, we try to know what the fluid will do to the environment when it is in static condition and when it is moving. That's it. Okay, that the simplest way to explain to you. Okay, when you learn fluid mechanics, okay, we try to answer, all right, the question of what the fluid can do when it is at rest and when it is moving. Due to what? Due to the environment. That's it. That's all. Okay. It's a simple thing. Okay. If you can understand it, so then after that we can use the mathematics. Okay. In order to determine what this fluid will do to this environment, we need to apply mathematics into it. All right. But the simplest thing is that we want to know what it can do. That's it. That's all we will learn in fluid mechanic 1. Okay, so first we will start with the static, all right? Or of course, we will start with static, all right? We're not going to start by running first, right? When you are born, you're not just running away. Then after that, you're doing static, okay? When you're born, you are static first, all right? So not moving. Okay, so when in the static, we only have 3 topics. Number 1 is the pressure. Okay, why pressure, sir? Because fluid, when it is at rest, it creates pressure to the environment. Okay, fluid doing nothing, just sit there. All right, just sit there. It will create pressure to the environment. Okay. Okay. I have these 1.5 liters of water here inside the bottle. Okay, it's doing nothing, just sit there. But it creates a pressure to this bottle. All right, it will create pressure to this bottle. How it create a pressure, sir? We will learn it later. Okay, it will create pressure. Okay. Oh, if the fluid is at rest, it creates pressure. All right. So do you remember just now I said our main objective is to determine what the fluid will do to the environment, right? So now the first thing the fluid will do when it is at rest is what? It creates pressure. All right. It gives pressure to the environment. Oh, it gives pressure, huh? Okay. If the fluid is giving pressure to the environment, we as a mechanical engineer, as engineer, say, whoa. If you give a pressure, so it will give effect to the wall or something, right? Right? It will give effect to the wall of something with holding the fluid, for example. Okay. So the next question is, how thick is the wall we need in order to hold to hold that fluid? All right. We need to determine how is the thickness of the wall in order to hold a fluid. Okay. Before we can do the thickness of it, we need to know what is the magnitude of the pressure, right? All right. First of all, we need to know what is the magnitude. When we know the magnitude, then we say, oh, okay, if this kind of magnitude, then the wall must be a certain centimeter, for example. All right. For the certain value, we need the diameter, the thickness of the wall, probably 1 meter, for example. Okay. So the first thing we need to do is what? Measure it. Okay, we need to determine the magnitude of the pressure. Okay, so the first one is measure it. So that's why you have this measure it. Where am I? Okay, so this is a measure it. Okay, we measure this one. Okay, how we want to measure it? Well, in the real world, they have a lot of these what we call a gadget to measure this pressure. But in our class, our gadget is only one by the name of manometer, because this manometer is the basis for all kind of measurement. All right, all kind of measurement to measure the pressure. Okay, so you will learn. All right, you will learn manometer to measure pressure. That's it. Okay. And then when you become expert in measuring this pressure, all right, and then we say, okay, now let's say we put something, all right, we put something, let's say a plane surface, for example, let's say we have a surface here, a plane surface, put it into the water, all right, put it into the water. Just want to test what the water will do to this plane surface. Okay, so when we put this plane surface into the water, we know the water fluid, when it is at rest, it will create pressure to the surface, right? All right, it will give a pressure to the surface. Okay, so since this surface having an area of A, all right, since having area of A, and then you have pressure in front of it, so by you learn it during the high school, for example, you know that when you have pressure and then you have area, you will get a force. All right, because pressure is equal to force divided by A. Now you have an area and then a pressure from a fluid, and finally you have a force. All right, a force which is acting on the surface. All right. Please remember again, we want to know what the fluid will do to the environment when it is at rest and when it is moving. So now you know that when we put something into the fluid, and then the fluid will give a pressure to the surface, all right, because the surface having an area, and then finally, actually, the fluid is giving a force to this surface. All right, this force is called hydrostatic force. Get it? Okay? Isn't that simple actually? All right? It's very simple. All right? It's very simple. The story is very simple. All right? So, you need to understand the story first. All right? When you understand the story, then we put all this mathematical behind that story. Okay? So, don't learn the mathematics, but we learn the concept first. All right? The story behind it. What actually happened? All right, so I just mentioned it to you just now. Okay, then after that we create equation. So that's why that equation we call it the hydrostatic force equation. Okay, and please remember a force, alright, a force which is on this surface here, okay, is a vector, alright? A force is a vector. A vector must have magnitude and direction. Okay, so if for the hydrostatic force, number one, you must know the magnitude. Okay, you must know the magnitude. How you want to determine the magnitude, sir? You will create the equation for it. Alright. Secondly, you must know the direction of it. Okay, the direction of that particular force. Okay, and lastly, you have let's say you have this area here, right? So the force that we just calculating just now using the equation, all right, is it on the whole surface here, or is it at one point? Okay, the next question that you should ask yourself. The force that we just calculate just now, sir, is it on the whole surface here, or is it at one point? Okay, so because the force actually is throughout the whole surface here, but we have million of forces here, all right, a million of arrow from the fluid is forcing on the surface. Okay, so we say, okay, I don't want to know the whole forces on each forces there. What we need to know is what is the average of it. Okay, so what is the average magnitude of force? So when you have an average, it means that we only have one force. That one force must be at one point. Get it? Okay, so when we talk about hydrostatic force and also the buoyancy, why buoyancy force? Why the equation is a funny equation there? All right, a funny spelling there. Oh my God! All right, I need to repair it. Buoyant. What's that? Okay. All right. So the buoyancy force is also a force given by fluid to a body. All right. So the buoyancy force and hydrostatic force is just the same. So every time when we have a force related to fluid at rest, then we must, all right, determine three things. Number one, magnitude. Number two, location. Number three is the direction. That's all, guys. Okay. Either hydrostatic force on the plane surface or a curved surface or a buoyancy force. All right. The only thing you need to determine is what? Magnitude, location, direction. That's it. All right. Oh my God, it's very simple, right? So that's why a lot of people get A in a fluid mechanic, you know. And most of the people pass the class. Because why? Because so simple. You see that? You only need to know what? What is magnitude? Okay, I will determine the magnitude. I have the equation. Where is the location? Oh, I know the location because I have the equation too. Where is the direction? Well, that force is given by the fluid. So if the fluid is on the right, so of course it will pointing to the left. It's quite simple. Alright? Because that force is coming from fluid when it is at rest. Okay. Alright, so that is a static. Okay, that is static. Next, fluid dynamic. Okay, next we have this fluid dynamic. We will start with the mass, all right, energy and momentum. Okay. Before that, we need to know the stories. Okay, everything actually in a fluid mechanic. First of all, you must know the story. Hey, what story you're talking about here? Okay, what is the story? Okay, now, just now, when the fluid is at rest, it's doing nothing, right? Just stay there, doing nothing. Okay, all right. And now, let's say this fluid want to move. All right, this fluid want to move. Hey, if you want to move from this point to that point, do you think it can move by itself? No. All right. This fluid cannot move from this point to that point by itself. It can only move, all right, when the fluid can only move when the fluid having enough energy for it to move. Right? So when the fluid is moving, all right, when fluid is moving, we say, oh, the fluid is moving from right to left, all right? So the fluid, actually, when it moves, it will move together, right? A column of it will move from one point to another point. Okay, so the question we want to ask is how many, all right, how many of this fluid is moving from right to the left? All right, so that's why we're looking for the mass of it. All right, so we're not looking for the molecule, each molecule is moving. No, we're not looking for the molecule. We're looking for the whole group of it moving from the right to the left. Okay, so this fluid can only move when it has enough energy. All right, enough energy. So you will learn how many mass is moving from one point to another point, and then how much energy that the fluid have in order for it to move from one point to another point. Or another question is, how much energy we should give to the fluid in order for it to move from this point to that point. Okay, where the energy come from, sir? From the pump, the one that I show you just now on the first slide. All right, from the pump. So that's why we say, okay, I give energy to the pump, and then the pump will give that energy to the fluid in order for it to move from this point to another point. Okay, so now imagine, all right, imagine we have a fluid here, all right, I have been given such a huge amount of energy from a pump, all right, so they have a lot of energy now. So it will start to move. Woo, all right, suddenly it strike the wall. All right, it strike the wall. What happened to velocity in the x direction? It will stop, right? The velocity is not, the fluid is not going to pass through this wall. All right, it will stop there. Imagine now the fluid having such a huge velocity, suddenly it becomes zero. All right, because of this wall. So what happened is that, all right, what happening here now is that we have what we call the momentum, right? Because they have an energy loss there. All right, it create they create momentum. Okay, so when the fluid is moved, the three things will happen at the same time. All right, the mass will flow, and then we have energy, and lastly they have momentum. All right, so these three, mass, energy, momentum, will happen at the same time. Okay, but in our class we're not going to calculate at the same time, right? We will look at in terms of one by one. All right, the mass, energy, and momentum. Okay, so after understanding the mass, energy, and momentum, all right, with all that knowledge that you have there, and then we apply it into the flow in part. All right, flow in part. Okay, so lastly, we have this dimensional analysis, which we learn about the Buckingham pi theorem, and also we learn about similitude. Okay. So what is the UTM expectation from you? All right. Number one, in terms of static, when the fluid is at rest, calculate and analyze shear stress in fluid flow. The pressure difference in the manometer, hydrostatic force on the plate and curved surfaces, buoyancy force and stability of submerged surface. So basically, you know what question will be asked during the test. All right, because why? It has been explained in detail in front of you here. In the static, they will ask you about what? Shear stress. And they will ask you about what? Manometer, hydrostatic force on the plane and curved surfaces, and also the buoyancy and the stability of a submerged floating bodies. In terms of dynamics, they ask you about what? About the Bernoulli equation, the concept of control volume, conservation of mass, energy equation, and also the momentum. You see that? So that's why I said it is easy for you to pass the class, or in fact, it's easy for you to get an A in this class. Because why? Everything has been explained it to you in front of you now. You know the question. You don't have to ask me, sir, what will be asked during the test number one? You don't have to ask that, because why? Everything is in front of you there. All right, and then flow in pipe, categorize, calculate. You see, number one, you need to categorize. Number two, you need to calculate, and number three, you need to analyze. What should we analyze? Sir? The major and minor losses. All right, for laminar and turbulent flow in pipe and pipe system. That's it. Okay, and lastly, for the dimensional analysis, identify number one, identify Second, derive, you create equation. All right, the dimensionless parameters for a given flow problem using dimensional analysis and similitude in order to solve various problem related to modeling. Okay, how we judge you? Okay, how UTM judge you? You have 10% or 10 homeworks. Okay, computer programming, and then test 1 is 20 mark, test 2 20 mark, and final exam is 40 mark. Okay, all right, so this semester you will have 10 homework. All right, 10 homework. If you submit all that 10, you get 10 marks if it is correct. Okay, if it is correct answer, then you get 10 marks. Okay, all right, I put another rules in my class. All right, the rule has been used for the last 30 years. Okay, the rule is that the minimum homework you must submit to me is 5. Okay, the minimum you must submit is 5. Those who submitted less than 5, automatically you will get E in my class. Okay, so by the, I think by the test number 1, all right, I think after test number 1, before test number 2, all right, before test number 2, I already can make the announcement to those who will be asked, don't have to take test 2, don't come to the final, and don't come to class anymore. Because why? It's already failed. Okay, so make sure you submit one at least 5. Got it? If you submit a 5 and then you get all correct, then you got 5 marks. Okay, so well, homework, something that you can do together with your friend. So why not try answer all that 10? All right, at least you got 10 marks for free. Okay. And next, what is next? Okay, this teaching, learning, and student learning. Okay, if you want to get an A, you need to spend your spend your life. Okay, how much? 120 hours. Dedicated to my class. All right. When you dedicated my your life for 120 hours, then you can get an A. Okay. In other words, it's not easy way. No easy way to go to heaven. All right. Okay. They have a lot of these. In our bahasa, we call it ranjau. All right, and all these problem before you can enter the heaven. Right. So you need to spend at least 120 hours. It is up to you. All right. I don't want to force you to give 120 hours for my class. Okay. You are an adult now, you can think by yourself, right? If you want something good, then you need to put more energy into it, all right? But if you say, well, it doesn't matter, okay, I also can give the same answer. Well, it doesn't matter, I just give you whatever grade I give to you, all right? Okay, if you are serious, I'm serious, okay? But if you say, well, it doesn't matter, it doesn't matter too, okay? All right, so next, what happened? Okay, so this is the textbook. Okay, it is better for you to have this textbook, all right, by Mercy Porter, all right, and you can get this either in E or you can have it in terms of textbook itself. All right, textbook itself. Okay, so this book will be used for Fleet 1 and Fleet 2. Okay, so it costs what, 90 ringgit or something like that. I'm not sure what is the price. Okay, if you want to buy the book, all right, if you want to buy the book, I can give the link to this distributor. All right, you can ask him, and then the rest is you can communicate with him. All right, this is the textbook. It is better for you to have this textbook because all the questions will be taken from the question of your homework will be taken from this textbook. Okay, I just give the numbers of the question. Okay, the question is inside the book, so you need to have the book. Okay, if you feel this book is so expensive because it's almost 100 ringgit, okay, if you feel it's too expensive, all right, you can make it cheaper. You can make it cheaper. Okay, because it is 100 ringgit, you use it twice, right? One is flip one, the other one is flip two. So basically, it's in flip one it is only 50 ringgit. Okay, another 50 ringgit is in the flip two. So it's quite cheap. But if you want cheaper than that, I can give you an idea. All right, use it to 4 semester. All right, use it 4 semester. Okay. How you want to use it 4 semesters, sir? Okay, never mind. This semester, take this one, buy this book, and fail. All right. So take another free one next the other semester. Okay. So you got 2 semesters. You already use it twice. All right. And then take flip 2. The first time you take it fail. All right. So because you want to make it cheaper, then you take the 4th semester you take another flip 2. Then you have 4 semester use it. So it become what, 25 ringgit, 25 ringgit. But if you think it is still expensive, then you can add another 2 semester. It becomes 6 semesters. All right. If that money is so become the what we call the hindrance for you to buy the textbook. Okay, so that's the way how to make it cheaper. Okay. Don't do that, okay? All right. Just an analogy I give it to you, all right, in order to tell you this book is very important, all right? Because in 50 minutes, what can I say in 50 minutes, okay? My joke is already half an hour. Okay, we have already only 20 minutes to talk about all these flip mechanics. So you need to read a book, all right? You need to read a book. So please find a textbook, okay? And at the same time, we have all these references, all right? All these references. You can use these references for your reference, all right? All the question will be taken from our textbook, okay? Hopefully you understand the difference between the textbook and the references, okay? And who will help you then? Okay, all right? Who will help you instruct you to help you, all right, to understand, to seek your knowledge about this fluid mechanic is by me, by the name of Muhammad Zubir Bahar. Okay, oh, by the way, my name is Muhammad Zubir Bahar. I forgot to introduce myself. Okay, I've been teaching this fluid mechanic since 1989. All right, you're not born yet, I think. All right, 1989. None of you are born yet in 1989. I already teach this class. So, you know, how long is my experience in this class. In fact, when I see your handwriting, I know you are copying somebody, you know. All right, the way you write it, okay, and suddenly it's jumping around. I know you must be copy somebody, okay. So don't bluff me, okay. I know already. Okay, so I'm beside as a mechanical engineer, all right, from University of Tennessee in United States, all right. I'm also certified as a professional machinery lubrication engineer and also lubricant analyst and certified as lubrication technician by the International Council for Machinery and Lubrication based in the United States, USA. All right. So I'm a certified related all this lubrication there. And I give a lot of talk for the industry, all right, throughout these right now up to Asia, the Asia country, and I am a certified ICML trainer and certified as the HRDS trainer in Malaysia. Okay, so if you have any question regarding to our class, for example, this is my email, but most of the time we will discuss in our group. Okay. Do you have anything else? Yep. That's it, guys. That's the end of it. Okay. So we have a few minutes. Do you have any questions before we stop? Because probably you have class after this. Any question, guys? I got one question.
Not really.
No question. Okay. I think I forgot something. Wait a minute. Yep. Stop here. Stop there. Okay. Tomorrow All right, tomorrow we don't have any class. All right, because tomorrow is holiday in Johor. All right, a public holiday. Okay, I will see you back on Thursday. All right, because I already shared with you the video by Dr. Hasbullah. So on Thursday, all right, we will go directly, all right, to the application of, all right, application of whatever Dr. Hasbullah been teach you in the video. Get it? Okay, so that's the way we will go in our class. Okay, Dr. Hasbullah will explain everything there, and then when you come to the class, we will apply whatever knowledge that I share with you in terms of the equation on everything. Okay, so in other words, we more on hands-on on the live class. Okay. Anything else, guys? If not, I stop here. Okay, we should stop here. I'll see you again next Thursday. Okay. Assalamualaikum and bye bye.
Thank you, Doctor.
All right. All right.
Doctor.